Mike here, glad you can join me. In this video, we're going to examine the moon rotating over various parts of the Earth, depending on our location. Here you're looking at Wolfie's eclipse video he had taken from Sydney, Australia, at August 8, 2017. And some flat earthers had messaged him and asked him why was his moon upside down, because in the northern hemisphere, the moon would appear to be rotated 180 degrees the other way. I messaged Wolfie and asked him how is it possible that his moon rotates 180 degrees from a moon, say, in Russia from the northern hemisphere. So he made me this video. In this video, he taped a ball at the bottom so he could show its orientation change as he moved the camera over the top of a globe. And, you know, this is fine. Of course, the camera is going to change orientation, but it really doesn't depict someone holding a camera and following the object in the sky above them. The heliocentric official explanation, when somebody asks the question, why do the constellations in the moon appear upside down from the southern hemisphere? And they say from the southern hemisphere, any object or constellation that lies near the celestial equator, the imaginary line that divides the northern and the southern halves of the sky, would appear both upside down and reverse to left to right compared to a northern perspective. And so, in other words, once you pass the equator line, the moon will reverse and the star constellations above will appear to be reversed. For example, in northern Australia, they can also see the Big Dipper as well as I in North America. However, the Big Dipper that they see in Australia is upside down from the position I see the Big Dipper. And so it brings to question, is this even possible, seeing that the stars are so far away, and what causes them to change their orientation so abruptly? I made a diagram to sort of show you what they're talking about. A person on the right side holding a camera to the moon will have their perspective of the moon change once they cross that celestial line to the other side. That is sort of what they're saying. In this photo here, I have a moon taken from Russia, the northern hemisphere, and Wolfie's moon is on the right, orientated exactly 180 degrees the opposite way. And so that was my question to Wolfie. How do you get a full 180 degree rotational turn when you're moving 30 degrees latitude north to only minus 30 degrees latitude south? This is the moon that we see on Earth when we look up into the sky. Sometimes it can be larger than this, sometimes it can be a little bit smaller, but we can always make out its surface details from our unaided eye. For example, we can see Tycho, that's 54 miles in diameter, without the aid of any optics or magnification zoom. I downloaded the Stellaris app to just play around with it, and I moved my location from the northern hemisphere to the southern hemisphere to see what the moon would do, and of course it flipped about 180 degrees. What I come to find out about these Galaxy apps is that they are designed to show the observer what they will observe on Earth when looking up to the sky in various locations. They do not at all take into account any numbers used by the heliocentric model. What I did was I just modeled the whole thing to scale. Now my biggest issue with this whole thing is very basic math, and you can see my two white lines on the screen. That is the measure of the angle from 30 degrees north latitude to minus 30 degrees south latitude. And if you were like to take a big lever and stick it in the moon in Russia and run down to Australia, you're only going to orientate or turn that position of the moon 1.5 degrees, not even 2 degrees. And what that means is you have a snowball's chance of flipping the moon 180 degrees from the northern hemisphere to the southern hemisphere. It's just not mathematically possible, and it has nothing to do with the curve, has nothing to do if the Earth's flat. It's just simply the moon is so far away. What I did was I modeled me a little man and I put a camera in his hand. We'll just say this camera is a P900, and this camera is pointed exactly at the moon. What I wanted to see and make doubly sure is that maybe the orientation did change. And so this is why I used a man to represent somebody holding a camera pointing at an object in the sky. So I'm going to show you what that looks like. We're going to start our animation. Here he goes, just walking along, walking along, walking along. And I kind of get a sense he's going to fall off the side of the Earth there as he's headed to Australia. But you can see that our camera is following the moon, and he's holding the camera and he's pointing straight up. Now right here, the camera starts to go slightly behind his head. But here's the thing, this doesn't change the orientation of the moon. He's only moved 1.5 degrees and according to the distance of the moon. And so it's just a matter of turning the camera around and facing the camera in a way that would be more comfortable for him to hold. Otherwise, people in Australia are drinking too much and they just simply have their cameras turned upside down. So now our guy is above Russia and he's pointing his camera straight at the moon. I've stopped the animation. As you can see, the moon from the human eye perspective, unaided at 238,000 miles away, is just a small white dot. That is exactly what we should see from any place on the Earth when viewing the moon without any optical aid. The moon is just simply too far away to make out any details such as Tycho, which is 54 miles in diameter, and we can clearly see Tycho on the surface of the moon. Just a reminder, this is what the moon looks like with the unaided eye, sometimes smaller and sometimes a little bigger. To see our moon a little bit better, I'm going to give him a much better lens. So let's give him a 1200 millimeter lens, such as Nikon sells for $180,000. Well, there's our moon. It's into view now. Next thing I want to do is run our animation of our guy walking down to Australia to see if our moon changes orientation at all. And so here I push play and we are now walking to Australia. If you notice, the moon, according to the heliocentric model, should flip at the equator center. However, we're getting absolutely no orientation change at all. The only orientation change we'll get from this view at this distance is the very slight 2 degree change at the bottom of the moon. And here we just zoom in a little bit and we are getting no change in the moon whatsoever, even though our animation is just looping over and over as our guy is walking to Sydney, Australia, and showing back up in Russia and walking back down again. Therefore, it is impossible for the moon to change any orientation while viewing it from the Earth, simply because it's too far away. Now, I was kind of wondering what it would take to get the moon to change orientation as it does. And the only way you're going to make that happen is you have to move your object closer so your angle is much greater from point A to point B on the path you're traveling. And folks, that's just simple math. And so the moon is now about 1,000 miles away. I couldn't put it closer, otherwise it would be hidden by the curvature from our guy in Australia. But as you notice, once we put the moon closer, we get somewhat the effect that we see in real-life observations when viewing the moon on Earth from different locations. We get almost, and well, probably the 180-degree turn. And as the guy is walking towards the moon will appear to zoom in simply because of the curvature rate of the Earth. And you can see the moon start to turn sideways there, just as we would expect it with an object that was this close to us. This tells me one thing, folks. The stars and the moon are but not even a couple hundred miles above us. Next, we're going to take a look at NASA, because in the Apollo photos, we see the moon very far away with the astronauts on the moon facing the Earth. NASA actually had this to scale. Here is a picture taken supposedly by the EpicDSCVR. No, it's not really a picture of the Earth. It's a rendered model of the Earth. You can tell by the Fresnel shading around the edges and the gloss shader used from the reflections that we often see in the center. Here is another picture taken by the EpicDSCVR supposedly, and our gloss in the center is much more prominent in this photo. And here we have our third picture taken supposedly by the EpicDSCVR. It's important to note that NASA claims EpicDSCVR has only a 4 megapixel camera, so right off the bat this picture is far too detailed for that camera, but that doesn't matter, it's a model anyways. And here we have a picture taken by the LRO. It is a one-pass shot, according to NASA, by the lunar orbiter, taking Earthrise pictures as it orbits the moon. However, this Earth looks really familiar, kind of like the last picture we saw from the EpicDSCVR familiar. And all NASA's doing is trying to now give us a visual of what we would expect the moon to Earth to look like, simply because of our visuals from the Earth to the moon. They appear much closer to us than what they really claim they are. And here we compare the EpicDSCVR photo with the photo taken by the LRO, and you can see there are many similarities, like the exact same cloud placement, the exact same continent placement, and the exact same everything. Oh, the LRO has a bluer moon, a bluer Earth than what the EpicDSCVR did. But outside of that, NASA just superimposed the rendered model they had of the EpicDSCVR onto a model of a moon surface and claimed it came from their lunar orbiter, which is a bunch of nonsense. We can't even get to the moon. And folks, they lie about this for a reason. That's because space above is absolutely nothing like they have told us in schools and through our news media, government propaganda. It is all a lie. They are hiding all this. Space is nothing at all, as they claim. Now, I really, really want you to think about this. For the moon to change orientation, how close does that moon have to be? Well, first of all, we'd have to know its size, but distance-wise, it can only be 100, maybe 200 miles above us. But that's not all. They claim that the stars flip orientation at the equator. Those stars are supposed to be millions of light years away. Now, if you think about the 2 degrees that I showed you that the moon would have to change orientation in, think about the 0.000 degrees the stars would be able to flip orientation. Folks, space is flat, it's dimensional, and it's above you, right above you. This is Mike. Like and subscribe.